And now to not be a zombie on stage because I'm back from the dead. I prefer Lich. This will be the most non-Selenium talk here probably today, because I'm not going to talk about code. I'm going to talk about where you run your code, because that is perhaps more important than the actual code that you run. So we'll start out with a story, a troll, and an easy prediction. So back when I learned how to do automation, this was the fall of '98, in order to, it was a terminal app that was running against an AS400, and it was interesting to set that thing up for test runs. Then went and joined a couple startups, and I literally had a rack of single-U machines in a data center that was my test environment, which was an absolute pain in the ass to, suddenly I remember I need to watch language because I'm being transcribed, to reconfigure between test runs, Ghost and network Ghost to restore machines every single run was non-pleasant, shall we say. So needless to say, when in like 2008, when EC2 came onto the scene, I jumped over that pretty much as quickly as I could, because I can spin up machines and destroy machines at a whim. And my consulting career, I did a whole bunch of sneaking continuous delivery and automation through EC2 via Selenium and WebDriver. So here comes the troll. I would argue that there are more Eclipse programmers, or IntelliJ, depending on who you hate more, than there are actually Java programmers. And if you're a Java programmer and don't like C#, you can say there are more Visual Studio programmers than there are actually C# programmers. So I would argue that in the same way, there are more EC2 users than there are AWS users. Spinning up machines and destroying machines is easy peasy, but doing it in a secure, performant, cost-effective manner is not so easy peasy and means that you have to become less of an EC2 user and really embrace AWS as a whole. And I found going into companies that they don't know how to do that. Their machines are insecure, they're overpaying for stuff, and they're wildly over-provisioning. So in my current role, I'm a CTO at a mobile marketing startup. I was, up until 2 years ago, firmly in the EC2 user camp. I've made a metric ton of, I'm Canadian, so it's metric, metric ton of mistakes and lessons learned. And I've had to become an AWS user. So this is sort of 2 years of mistakes encapsulated that apply directly to running your scripts inside of the AWS cloud. So the very first thing you need to think about, and some of this stuff may be above your pay grade, but you need to understand it because at some point it won't be above your pay grade. As soon as you create an account with AWS, you need to, nowadays, you get given a default VPC, Virtual Private Cloud. So there are 4 general architectures you need to worry about. Basically, you can have one monolithic VPC where everything is in that. Very bad idea. Don't do that. Every environment, so test, staging, production, is in one VPC but has different subnets, and so that's, there are nuances there. That's not so horrible. That's what, that's how I'm presently running my infrastructure. Had I known then what I know now, I would have done option C, which is multiple VPCs, so that there is a separation of concerns between them. But if you're in any sort of highly regulated environment, like if you need to be HIPAA compliant, you need to go for option 4, which is multiple accounts. And so there's very big walls between them. There are billing implications, there are networking implications. But understand that there are multiple architectures that you need to worry about. Personally, I would go with multiple VPCs, especially for the automation context. You have the automation VPC. All right. So, first thing we need to talk about is a bit of security. The very first thing that you need to do when you create an account is enable multi-factor authentication for every single user that can log into the whole system. And that is in terms of either a digital token that sits on your phone or a physical token that hangs on a lanyard. Your security regime will depend on which one you use. Personally, for 98% of use cases, the virtual token is fine on your, is more than sufficient. There are some tricks to it, like if you change time zones, you have to resync it. I was in Sweden at a conference and panicking because something was down and I could not log into the system until I resynchronized everything, and it was fine. But the one account that must absolutely have a physical token, not because it really does, but because I say it does, is what's called the root account. That is the account that can do anything else on your account, provision other users, etc. That should have a physical token. They're about $45 on Amazon. It sits on a lanyard hanging in the office somewhere that everybody knows where it is, and it won't get lost. If it does get lost, it's kind of a pain in the butt because you have to call Amazon and ask them to reset your token and prove that you are who you say you are, which means sending like articles of incorporation to them and what have you. There are scripts that you can, policies that you can create that limit access to things based upon whether or not you have authenticated with a token. I have an article that will be somewhere in the web this week that has sample scripts to how to check your users for if they have a token enabled or not. But there are ways to do that. The next thing you need to talk about is access keys. So when you create a user inside AWS, so the root user has created an IAM user, you have the ability to generate up to 2 keys for them. Do not use these keys for your infrastructure. There are ways to have Amazon components talk without keys. The keys are there for you as a user to access API endpoints, to look at things, but not necessarily to spin up things or have communication between them. And the reason for this is if your infrastructure relies on access keys and say somebody checks their AWS credentials file into GitHub publicly, and I'm certainly not suggesting that you search GitHub for .aws/credentials and run people's bills up, because that would never happen. If it's compromised and you have to rotate it suddenly, all your infrastructure falls down, and it's going to fall down in unique and wonderful ways that you didn't anticipate. So practice rotating your keys. That's the other thing that I've learned here. Again, not that I've learned any of this stuff myself. Practice rotating your keys. It's just like backups. It's not enough to say, oh yeah, I took a backup, but you have to practice the restore. So practice rotating your keys and see what falls down, because that's a bug in your infrastructure if something fell down. So here's the biggest thorn in my side right now that I wish I had known, because this is basically how I'm going to spend the rest of this year backporting this bit of knowledge into my company's infrastructure. For reals, treat your infrastructure like code. If you log into the console to create anything, it is a bug in your infrastructure. So if you are logging in to create an EC2 instance, to create an RDS instance, Elasticache, Elasticsearch, any of these things that your infrastructure is going to need to run your automated test, and you log in to do it, you are setting yourself up with some infrastructure debt that is going to be a pain in the butt to pay back, especially if you're trying to pay it back against running production systems or that are built into your pipeline. So what CloudFormation is AWS's infrastructure as code product. You describe things in either YAML or JSON. It's complicated as all get out. But if you can figure out how to run this stuff, you are ahead of about 99% of people that call themselves test engineers, and you are probably ahead of about 75% of the people that call themselves DevOps. Because this is truly AWS knowledge, not just EC2 knowledge. And so there's entire workshops that can be run on CloudFormation, but you can create any resource in code, light it up, and it just appears and will register. And all this stuff starts to chain along, and it'll become a little more clear why this is important. But of course, CloudFormation is just text files, so you can check them into your version control system, because everybody uses those now. And you can diff them and treat them like you would code assets. I also firmly believe that for your testing infrastructure, automation, or manual, everything should be inside what are called auto-scaling groups. And this is generally sold to organizations around the benefits of elasticity. You get put onto the front page of Reddit, and you can spin up your infrastructures to handle the load. Which, in our testing infrastructure, in theory, no links on Reddit should ever be pointing to your test infrastructure, because that's nice and hidden behind a firewall and stuff. But this is really important for test automation, because when the automation's not running, you can auto-scale it to 0, which means those resources go away, which means you don't actually pay for them anymore. Amazon bills by the hour or the partial hour. So if you are only running your scripts during office hours, 9 to 5, come 6 o'clock at night, have it automatically scale down to 0 and light back up at 8 o'clock in the morning. You just saved yourselves, it works out to $1 under $2 a day or $1 a day, but over the course of a year, or especially if you're running in massively or massive grid farms, that's going to save you a lot of money. But there are, once you're inside using auto-scaling groups, which again you are creating through CloudFormation and bringing up machines, you need to worry about configuration management, because you are not logging into these machines to manually set any flags or settings, or when the machine comes up, it has to be ready to go. And typically this is done through tools like Ansible or Puppet or Chef, or even to some extent you can use what's called Cloud Init. It's that user data section. When you light up an EC2 instance, you can do magical things in there. Through flukes of history, I'm a Puppet person. I had all our infrastructure using the classic master-slave scenario. But when I went to auto-scaling groups, that falls down really, really quickly, because authentication is based upon certificates, which are based upon the host name. And if you've got machines coming and going willy-nilly, you end up with certificate clashes really, really, really fast. So now I have had to move to what's called headless Puppet, which has its own fun challenges. But were I to do it again, I would probably use Chef using OpsWorks, which is Amazon's configuration management tool set. So when a machine lights up, it automatically registers, and OpsWorks is based off of Chef. So when an instance in an auto-scaling group lights up, it registers with the Chef server, it does all the authentication and figures all that stuff out, and dumps the configuration onto the machine, and is available as a node in the auto-scaling group and in your load balancer and all that stuff when it's completed. It's kind of magic, but it's really, really important. You should never, how should I word this? If you find yourself trying to memorize IP addresses of boxes, you're doing something wrong. Because why are you logging into that machine? Oh, I need to make a configuration change. No, that means you've got a bug in your configuration management, in your setup, your auto-scaling, your whatnot. I'm going way too fast. Okay, application logs. This follows along with the idea that you should never, ever log into your boxes ever again. So you're running your scripts, something went wrong, and you're like, well, did it blow its top and dump something in the logs? Or maybe we've got crazy debugging on, so we can wind back and figure out the challenges that, or what was going on in the logs at that point of time when it failed. Again, you're not logging into the machine, so you need to have some way of getting those logs. So you need to have something like Logstash or Splunk or whatever, centrally managing your log files. And hopefully your production people are using something. You should probably use what they're using to capture these logs. And so you can get the error logs sent directly to a shared inbox, say, or log into whatever platform you're using for your log management to see what was happening. Because the IP address of this machine is probably different than it was an hour ago because it's a different machine. Some people say, well, we can just read the logs inside of our app. And that works fine until you are behind a load balancer and you have multiple nodes. And so you're looking at a log and then you refresh the page and the log's different because you hit a different node. Some frameworks make that easier or harder to look at. To do it that way, our app is in Laravel, which some of the decisions drive me bonkers. The notion that it will never be behind a load balancer and have multiple nodes running concurrently seems to be baked into Laravel. So our option is to do application logging. Our example, the example specifically for our app, what we do is if there's an error log, all of our logs from our app get dumped into Elasticsearch that we can look at it later. But if it matches and if it says like environment.error, then the simple notification service gets told about it, and then it fires off an email that lands in our phones. So this comes back to another security thing. We talked about like application logs, but there's the larger logs that you need to care about as well. And these are your infrastructure logs. These are the actual AWS level logging. There is a part of the AWS toolkit is called CloudTrail, which will log every single interaction with any AWS API call in that account. I went to the big AWS conference 2 years ago, and every single talk somehow snuck in, turn on CloudTrail, turn it on now, and leave it on. And because this is how you tell that somebody is doing nefarious things in your account. So your testing infrastructure may not be production infrastructure, but it still needs to be secure, especially if you're doing dumb things like copying production databases down to test for real data loads. So yes, everybody, go home, or not even go home, at the break, log into your AWS account, turn on CloudTrail for every single region. If your account is compromised, whoever you have, like the AWS person that you call for help to figure out what the heck just went wrong, or the third-party security team, they're going to say, we need access to your CloudTrail logs. And if you say we don't have CloudTrail turned on, they're like, yeah, we don't know what happened. There's a script that will be in the article that's associated with this with this talk later this week that will tell you which regions have CloudTrail turned on or off. I just have that running as a cron job on an operations machine, and if any of them say it's disabled, I get notified. You can do funky things like if CloudTrail gets turned off, then the last entry in the CloudTrail log will be, I'm turned off, which you can then have CloudWatch catch, which can fire off a Lambda function, which will turn CloudTrail back on. So there's a whole bunch of funky things that once you start becoming an AWS user, not just an EC2 user, you can do there. The other bit of infrastructure logs that I don't know enough about, but I'm being told repeatedly that I need to know about, is VPN or VPC flow logs. And basically that is all of the traffic that flows in and out of your VPC. So you can monitor, is certain subnets having access to other subnets? Are they supposed to? Did I break a security group? Why are things not going through? Am I being denial of serviced? Where am I being denial of serviced from? Is it actually just another server that's denial of servicing me? Because none of us have ever run performance tests on our network and not told another part of the organization, and then had to figure out why things fell down. Don't do that when your CEO is presenting. So infrastructure logs, the primary ones, CloudTrail, VPC flow logs, turn them both on because I say so, because AWS told me to say that. So tagging. I keep falling in and out of love with tagging. I know that I need to do it, but I'm lazy, and I end up not doing it nearly as much as I can. I'm also indecisive, so I don't have a naming convention for tags. Both of these things are important. So let's wind back a half a second here. Most resources inside AWS can have up to, I think, about 50 tags associated with them, name value pairs. Initially, they were for billing purposes. So this EC2 instance is for client X. This one's for client Y. So then when you get your bill, which is, there are entire talks about how to decipher your AWS bill, you can suddenly say that, we are charging client X $50,000. Their resources are costing $60,000. That's out of sync. We are losing money on this client. We should probably fix that. In the automation context, your automation infrastructure probably should have a resource tag like, is automation infrastructure true? So that way you can look at your monthly AWS bill and say, how much does our infrastructure cost for our automation? Because nobody's ever been asked to quantify the costs of automation before, and nobody's ever gotten in trouble when you just say, well, we can't estimate this. What is the cost of a bug going into production? But at least this is a quantifiable number that you can say the execution of the scripts costs X. And some number is better than no number when having to justify costs. So tag everything for your infrastructure. And CloudFormation makes it really easy to do that, because you can say when you are defining all of your resources, this is the tag that gets applied to them. If you are still backporting in your infrastructure into CloudFormation, you can use AWS config, which is like an auditing tool inside AWS. You can set up rules that say, does this piece of infrastructure have this tag? Does this tag look like this regex? So when you are doing these things, tag everything. But also, give some consideration to your naming conventions. This applies for pretty much everything inside AWS, because everything needs a name. Are you using hyphens? Are you using periods? Are you putting the region dash availability zone dash name of thing dash some number as your name? Because once you start scaling out into different availability zones, things like security groups apply to one availability zone, not all of them. So now which security group am I looking at? Or am I applying to a resource? I'm applying the one that is in Asia Pacific to Europe. That doesn't work. That takes a long time to debug. Again, not that I've ever done these things. So AWS config will tell you what machines are non-conformant. Treat non-conformant items as bugs in your infrastructure. I keep saying bugs in infrastructure. Legitimately, in your bug tracking system, keep track of these things as bugs. That's what they are. They aren't just like to-do items on some DevOps's whiteboard. They are bugs in the infrastructure. This is infrastructure as code, code has bugs, therefore bugs in the infrastructure are tracked as such. Again, here's one that certainly I did not need to fight with while tweaking things in production just the other weekend and learned this one the hard way. Certainly not. Do not put IP addresses in any of your config files. Because again, if you are doing auto-scaling groups and whatnot, machines come and go, or CloudFormation because certain things need to be recreated instead of can be tweaked in line. Don't put IP addresses in there because suddenly, say, your Laravel app that uses Redis as a session manager can't actually contact the Redis server because it doesn't actually exist anymore because it's now a different IP address, and now your customers in the middle of a launch are seeing a 504 page. All strictly hypothetical, of course. AWS, unsurprisingly, has a DNS server called Route 53. Anytime your infrastructure is changed by CloudFormation or auto-scaling groups, you can use the API to register that current IP address with a name inside Route 53. So you could have cache.humans, which is one of our environments, the internal.mobilexco.com. And it doesn't matter where that cache server is anymore because when it comes up, it's going to register with that domain or with that record inside DNS. So now we can do anything we want with our infrastructure. We can shut it down. We can scale it all down to 0 because we're not using that environment over the weekend, and we bring it back up, and everything is connected and wired together. There's also this notion of, and this is one thing that I'm still working my way through. Route 53 has this notion of public DNS and private DNS. Private DNS is only available internally to the Amazon ecosystem. So I don't think that your automation machines and automation servers, etc., things that they need to operate, need to be in the public DNS. That's just leaking your infrastructure out. That's kind of a classic social engineer, figure out what the infrastructure looks like so you can exploit it, script kiddie trick. So you probably don't want to have that in there. So you use your private DNS, can't get access from outside of AWS. With the caveat, again, certainly didn't learn this one the hard way, if you have the same domain as both a public DNS entry and a private DNS entry inside Route 53, it starts doing what's called split horizon DNS. And suddenly your internal machines can't contact the outside world because DNS collisions happen, and it may or may not take you an hour or so to figure out what the heck goes wrong, and then may or may not take DNS a while to propagate changes back around, all the while the boss is trying to do a demo to a client. Again, never happens. So that's, the high level, at the bare minimum, that's the AWS stuff that you need to know to be an AWS user rather than an EC2 user when running your grids. Like, I would imagine that the majority of people that are just running single instances for their automation or grids inside AWS are firmly in the EC2 camp rather than the AWS camp. I would argue that, well, actually, I'll pull back to a slide that I totally forgot with like one of my snarky lines. When I started automation in '98, in order to be a senior automation expert, you needed to be able to push a button that said record, and you needed to then push a button that said play. And if you were really top of the crowd, what you did was you were able to replace hard-coded values with values from a CSV file. Like, that was super trick on how to do. And so then we've moved away from that, and we now recognize that automation is programming. In order to do good automation, you need to be a programmer, and I will challenge anybody who says otherwise. And that's where we're at right now. I would argue that 5 years from now, in order to be an automation specialist, you need to be able to program, but also be able to run the AWS stuff. So this is as the current world sits, base things that you need to know on that. So that's the infrastructure part. So I was feeling a little guilty about not actually having any, like, here's how you write tests for the Amazon. So I threw some in. Everybody knows that Amazon has absolute 100% uptime, and it never certainly, engineers in Virginia certainly never ever fat finger a config file and take down S3, which is kind of the core system for everything in Amazon, leading to at least a 6-hour outage. Last month, it legitimately was. They were following a script, typing a command, and they fat-fingered one character, and they pulled down the largest region in AWS. So we all know that Amazon has 100% uptime. So our scripts should just assume 100% uptime, of course, except that if you're cynical and don't actually believe that Amazon has 100% uptime. Oh, the best part about that outage, just to totally deviate for a second, was that they broke S3, which is what they needed for which is what their status page needed. So their status page said everything was up, except that everything was down. And the very first thing they had to fix was their status page so they could communicate to the world that they were down. So a number of years back, I think it was Netflix who got a lot of press with their Chaos Monkey, that they just randomly shut stuff down. I'm quite convinced that if you're running your automation, or especially if you're running your production load inside Amazon, have a Chaos Monkey daemon running somewhere in your automated test infrastructure. Your automation is, we're writing Selenium scripts. They're in the browser. We are emulating user behavior. The users are going to be using your app when Amazon, falls on its face. So write your script, write this little nasty little daemoner that goes just around and select a random number between 1 and 1,000 every minute. And if it's a certain number, pick a random, do a search for things that have your infrastructure tag and just delete it. And does your app stay up? If your database goes away, what happens to the end user experience? Do they get a generic load balancer error page? Do they get a branded page? Are you doing some funky round robin uptime stuff inside Route 53 that kicks in? It should be transparent to your user. Or at the very least, you should understand what happens when that component goes away. Production is not the place to be doing that testing. There is time and a place to do testing in production. What happens when you kick the cache server out of the mix is not one of those things. So design your tests for actually running inside the cloud. It's supposed to be a safe infrastructure to do that. Also, design your tests as if they were going to be run in production. So one of the great things about Amazon is that it makes it really easy to do zero downtime deployments. Like, there is no excuse anymore for having any downtime to the user when changing the code that is in production. Now, you can certainly have, or I suppose it should be unexpected downtime in production. Like, we don't do zero downtime deployments because our traffic and our load patterns are not worth the effort for us to do zero downtime deployments. It would cost us more than it would save us in user inconvenience. But we're still small. Most of the people here are going to have great inconvenience if there's downtime in production, even if it's just for 10 seconds while nodes reset. So what you can do using AWS Code Deploy and Lambda and their application load balancers or Elastic load balancers is pull nodes in and out of production, change the code, test that it's OK there, then add it back to the load balancer, pull the next node out, et cetera, et cetera. You can have zero downtime deployments. It's possible. This is not cutting edge anymore. So why not have your testing infrastructure do this stuff as well? Again, talk to your ops people. Maybe how do you deploy the code? if you've got a 2-hour-long set of WebDriver scripts that run, do a deployment in the middle. What happens? None of your scripts should fail, because your users will be interacting with your system while the code is being deployed. Again, we are acting as the users in a browser. Again, this is the troll that Simon had around Phantom.js. Nobody actually uses Phantom.js. So glad to hear that Simon's saying it, because I've been saying it for a decade. Maybe now people will listen to it. So those are my 2 tips on how to design for running your scripts inside AWS, especially if you're running your production load inside AWS. And I suppose if you're running inside Azure or Rackspace or something, they have their own branded versions of these things, but the concepts apply. It's just like if you are a programmer, you can pick up other languages, right? You know, I'm a Python programmer by trade. I picked up Rails or Ruby, which really I learned Rails, not Ruby. That's another snark in there somewhere. I picked it up in like 2 weeks because it was just a matter of syntax to figure out what was going on. And then I had to figure out why the developer I was taking over from had overridden the addition operator. The answer seemed to be, well, because he could. The synopsis of the talk I sent in said that I would give you a checklist of things that you need to do. So here's a checklist that looks a lot better in Markdown than it does inside Keynote. So here are the things that you need to do for your infrastructure. You need to double check that all your IAM users have multi-factor authentication turned on. You need to make sure that your root user for your account has a physical MFA token, not a virtual MFA token. You need to make sure that none of your IAM access keys are used for actual infrastructure purposes, and that you practice rotating your keys. Because at some point, somebody will release their keys. Either they will check them into GitHub, or they'll have their laptop stolen, and they are in their .aws directory on their unencrypted drive, and now your entire infrastructure, depending on their level of access, has now been owned. Your root user does not have an access key, because that you can do anything you want there. You can even create sub-accounts that get sent to a different billing address, and now you are running up somebody else's bill. CloudFormation makes absolutely everything inside your system. You do not ever log into the console to create a piece of infrastructure. Application logs are stored centrally, collected through Logstash or something. One thing I didn't touch on, but it falls in line under the configuration management, is that you are not logging into your server ever, ever, ever. EC2 has this thing called the Systems Manager, which allows you to run shell commands against machines. So you register a command in the Systems Manager, and you say, go run this command against this fleet of machines over here. Against this Autoscaling group, I want to run the kick the server because it's lost its mind command. You are not actually logging into the box to do it. You have enabled CloudTrail on all of your regions. That's the one that you can do right now. In 6 minutes when I finish up, you can log into your account, and if you don't have access to that account, but you can see that it's not enabled, you need to, or if you don't have the ability to turn it on, but you see that it's not, you need to go yell at an ops person and sound all smart saying there's this security thing that you're not doing. Your flow logs are enabled. You have decided on a naming convention for your resource tags, and everything in your infrastructure has a resource tag, because then you can see exactly how much money it costs you to run your automation. And finally, your application is dealing with infrastructure not by IP address, but solely by DNS name, which is crazy enough getting updated when you run things in CloudFormation or as part of an auto-scaling group. So then that, with me talking really fast, gives me 5.5 minutes that I didn't actually plan for. So I guess we do questions. Only on me. People can like walk around and talk in my throat, I suppose. Might be awkward.
Don't dare them.
I'm 6'4", so it really is like the right height for the majority of people.
Quick question. So what would you say is your best recommendation on like a guide for learning AWS? Where would you go if you were just starting?
So every year, the question was, where do you learn all this stuff? Every year, Amazon has a monster convention. I think there was 35,000 people at it last year, called AWS reInvent. And every single talk is recorded in crazy HD, and most of them are by actual product owners inside AWS, so they actually know what they're talking about. And so you just start to deep dive into those things. Like if you're looking at identity, like IAM, which is identity and access management, there's probably 40, 50 hours of videos at this point on getting started to advanced debugging techniques and controlling policies between users, between groups. So that's probably where I would start first, is at the actual reInvent videos. I learned a ton when I went 2 years ago.
I actually have a question, Adam. How much time do you spend hacking on the Amazon API via language SDKs as opposed to just writing YAML files and stuff like that for the configuration that you check into your VCS?
I'm trying to spend more and more time writing, in this case, JSON files to do everything in CloudFormation. Because I spun up our production infrastructure by hand, I am now trying to sneak in and backport all the things that I said that you should do into our infrastructure. Which is really, really hard without actually running a completely parallel infrastructure, which is costly. So the end result is, the honest answer is I probably spend 30% of my time writing these files. The desired answer is I should be spending 100% of my time writing these files. But I've got a pile of infrastructure debt about this high that I'm slowly chewing through.
Is it possible to create like IAM roles from code as well? Like, is that something CloudFormation does, or is that like the one time you log into the UI?
Yeah. So the very first, so when you create the brand new account, lock down the root account, create an IAM user, give them permissions to run things through CloudFormation, and go from there. Is the ideal world. You can create IAM roles, users, policies through CloudFormation. So then you just you have your different templates. Templates can become stacks, and you just chain all of your stacks that do different components together.
What's your thought on managing the PEM files?
Sorry?
PEM files for EC2 instances. What's your thought on that, managing them?
Managing?
The PEM files, PEM, the keys.
Oh, the public key files? Well, again, that's like in your infrastructure. It's just a configuration management thing at that point. So the challenge there is when you create a new EC2 instance, you need to say, I have this public key that I need to log in as the Ubuntu user or EC2 user if you're using the Amazon images. There are lots of tutorials and opinions on how to manage those things. Essentially, it's a configuration management problem. So there could be when the machine lights up, depending on which infrastructure, it's the automation infrastructure. So all the automation folks, they have their keys dropped on that user, and then you remove the default one. There are pros and cons to many approaches. That's, in our case, we've got a very small team, so I just drop the keys that need to be there onto the box at boot time. And because Puppet will pull for new changes every 15 minutes, if I need to remove a key, then it's gone within 15 minutes.
Yes.
So,
We are at 0 time, according to the clock. And there's people trying to get in for the next one. So I will be clearly hanging out the rest of today, tomorrow. If you have AWS questions, you can come ask me.